If we're solving a quadratic equation, that means that it's something with a degree of 2. The first thing that has to happen is we've got to get everything on the same side with 0 on the other. Next, we'll factor, set the factors equal to 0, and solve from there. Now, for this particular problem, I've already got everything on one side with 0 on the other, so the first step is taken care of. Next, I need to try to factor the things that are on the left-hand side, following all the rules for factoring that we learned before. First, look for something common. There's not anything. Then count the number of terms. Looks like there are 3, but it's a general trinomial instead of a perfect square. That means I'll put down 2 sets of parentheses. Now, to get an x squared on the front, we would multiply x times x. To get a 2 on the back, the only way to do that is to have a 2 and a 1. The signs here are going to be the same. They're both going to be negatives. So there is our factored form. Now, the reason that we wanted everything together on one side with 0 on the other is now I have 2 things being multiplied together and their result is 0. Anytime that you multiply 2 things together and the result is 0, this means somebody there has to be 0. So what we'll do next is to set each factor individually equal to 0. We'll say, what if it's x minus 2 that's the one that's 0? Or maybe it's x minus 1 that is the one that's 0. Now let's just solve these equations we've created. Moving the 2 across, one of my solutions is x equals 2. Moving the 1 across, the other solution is x equals 1. Notice that there are 2 solutions. When you have a degree of 2, the maximum number of solutions you can get matches that degree, so the maximum number of solutions on a problem with a degree of 2 would be 2. Notice that the word is maximum. This is the most that we could get. There might be fewer solutions, but there can never be more. Now, what these solutions are ultimately going to mean for you, they will be places on the Cartesian plane where a graph is crossing the x-axis. So when we draw a picture of x squared minus 3x plus 2, the fact that it's a square makes this have a shape called a parabola, and it will pass through the x-axis at each of those values, 2 and 1. Here is where x equals 1. Here is where x equals 2. When we get those solutions, that tells us what the 0, the root, the solution, the x-intercept for the polynomial would be. Let's try another. Now, if I want to solve this one, the first step is I've got to move the 10 across so that it is on the same side with everybody else. As I move it across, it's changing from a negative to a positive. Now let's factor this as much as I can. It is a general trinomial, so I'll need to say x times x to make an x squared. The signs are again the same. They're both going to be negatives. We can go ahead and place those signs in the parentheses. Now 10 might be 10 and 1, or it could be 5 and 2. It's almost never the something and 1, so let's guess 5 and 2. I need to check and be sure that this gives me the right middle term, since I had choices this time. On the outside made a minus 2x. On the inside is a minus 5x. Minus 2x minus 5x together makes minus 7x, so we've got it factored properly. Now take the factors and individually set them equal to 0 to be able to get to our solutions. Moving the 5 across, one of the answers is 5. Moving the 2 across, the other answer is 2. I've got 2 solutions. How many solutions? There are 2. We had a degree of 2, so the maximum number of solutions we could get matches that degree. Now, you may pretty quickly decide that there's no need for you to set the factors equal to 0. You may very quickly decide that you can jump straight from the factor to the solution by noticing that the solution every time will be the opposite of the constant value divided by whatever coefficient that we have. Opposite of negative 5 is positive 5. Divided by 1 gives me 5. Opposite of negative 2 is positive 2. Divided by 1 gives me 2. You can jump straight to the solution from the factor by doing the opposite of the constant divided by the coefficient. When you're solving something quadratic by factoring, get everything on the same side with 0 on the other. Factor as much as you can. Set the factors equal to 0 if you like, and then solve from there. With a degree of 2, the maximum number of solutions you can get will be 2. And remember, those solutions are ultimately going to be places where we cross the x-axis.